This is example 1 from chapter 8, section 3. You remember we've been talking about some of the ways you can show that a quadrilateral is a parallelogram. And so we'll talk about this in a second here, but let's read the problem here. In quadrilateral WXYZ, the measurement of angle W is 42 degrees, the measurement of angle X equals 138 degrees, and the measurement of angle Y equals 42 degrees. Find the measurement of angle Z. Is WXYZ a parallelogram? Explain your reasoning. So I'm going to just sketch what might be a parallelogram and then label the parts I know. So here's my parallelogram, potentially, something like that. And we're just going to label it in order here. So W, X, Y, whoops. We'll call this Y. Here, I'll erase that. Y, Z. Okay? And it says W is 42. Okay. X is 138. And Y is 42. Okay. So what do the measures of a quadrilateral add up to? Of the angles add up to? So we can use n minus 2 times 180. Okay, and we know n is 4. So we know this equals 360. And so I'm going to subtract the 42. I'm going to subtract the 138. And that gives me a total of, just get my calculator out here and we can figure it out. Okay, so this means the measurement of angle Z equals 138 degrees. So I can put that in there. Okay, so I'm going to erase some stuff here. So you got that work there. I'm going to erase it so I have the space here. So we know all the angles. That should help us here. I erased the W. Okay, it says, is it a parallelogram? Well, one of the theorems, and parallelogram theorem, says the opposite angles are congruent, and it looks like that. Looks like W and Y are congruent, X and Z are congruent. So I would say W, X, Y, Z is a quadrilateral because its opposite angles are congruent. There we go.